Okay, so if we're going to rotate this about the y-axis, we're going to use the shell method. What we want to envision is we want to envision these shells, right, like this, going down to there and up. So we have a little width of this shell, tiny width of the shell, and that's going to be dx because it's in this left-right direction. The radius itself is going to be x. So we already know that we're going to have an integral. It's going to be 2 pi rh. We know it's going to be dx, right? The other thing you know is that the 2 pi can come out. All right. You know that the r is actually just x. And the height is going to be the distance between this line, that's y equals, what is it, 1? And then this line right here, which we have to solve for in terms of y. Okay?
1 minus.
Sorry, 1 minus, yeah? The top line is 1, so don't forget that. You got to do 1 minus this. So we have to get this in terms of y. Now, what's our limits of integration? Well, again, it's going to be with respect to r here, right? Or with respect to x. So we want to go from a radius of what would be 0 to a radius of what would be the intersection of this, okay, where y equals 1. So if y equals 1, what is that? That's tan of pi over 4.
Wait,
So what's the tan of pi over 4?
1.
1. So this is 1.
Oh, you're looking
You get that? I'm just looking for this upper limit of integration here. So if you put 1 in for y, you get x value is tan of pi over 4, which is root 2 over 2 divided by root 2 over 2.
Yeah.
Okay, so we go from 0 to 1 here. Now, as I mentioned, we have to go ahead and take this, and we have to write it in terms of y. So how are we going to do that? Well, let's just do that over here, and I'll erase it later. So this is our function. In order to get rid of this tan, we're going to do tan to the negative 1 for both sides, right? Which is actually arctan. You with me? Now, arctan on the calculator, as I think I showed you guys here just a minute ago, is tan to the negative 1. So second function tan, that's arctan on your calculator. So we're going to get to that. So to isolate for y, we multiply by 4 divided by pi. So 4 arctan, or 4 over pi, arctan x. All right. So if this now is y, then our height, the height is going to be y equals 1 minus y equals 4 over pi arctan x. So 1 minus 4 over pi arctan, which I guess we'll write like this because that's what our calculator is saying. X dx. And no, I wouldn't expect you to manually here find this integral. It's a bit complicated. So we can do it with our calculator, so let's give it a try. All right, so do we need to expand this? I guess we could, but we could also just type this whole thing in the way it stands right there, I suppose. Okay, so let's do y equals, let's do x times 1 minus, this is going to be 4 over pi times the second function of tan of x okay, so 2 brackets there, right? Does that look okay? I'm not sure what the what this graph is going to look like here. My window's a bit funny, but I want to go from 0 to 1. Oh, okay. So let me just zoom in here a bit with this window here. Let's go from negative 1 to 2 and see what we have there. What? Did you uncover something inappropriate on your calculator?
No, she insulted me in calculator.
Okay. All right, so do you see that this integral between 0 and 1 is going to be the area underneath the curve, so this little area right here?
Yeah.
All right. So how do we do that again with a calculator? Second function, trace, and it's this one here, isn't it? Number 7. Okay. So lower limit, you can just type that in, right? 0. We want to go from 0 all the way to upper limit of 1. Hit enter. It should fill it in for you. So it shows you where you're measuring, and then it should give you the value here, 0.1366197. Uh-oh, what was it? 0.13.
You're wrong.
.13666977. Okay. 0.136619. Yeah. 19. Okay, so multiply that by 2 pi and you should get your area. So let's see if that, now it's going to be a decimal, right? You see that? Because we haven't, like this answer right here that you see right here, 4 minus pi, we're getting an approximate answer because we're using the calculator, heaven forbid. But let's give it a try anyways. So let's quit that, and let's say 2 pi times 1366197. Yeah, make sure you do times 2 pi. And we get about 0.8584. Now let's just test to see how close we are. 4 minus pi, that doesn't look like it's going to be too far off. Look at that, pretty close. So what we've done with the calculator is good, and like I say, I won't expect you to get the exact answer. You can use your calculator for this type of question. All right? Now, if you use the disk method here, okay, you should get the same answer. And disk method actually, yeah, it would probably be easier to get this exact value, I suppose, right? Because you wouldn't have to change this function into y equals. You could just use tan. You know the derivative of tan, blah, blah, blah. So you could keep it with exact values. All right? So just wanted to let you know that you could use that shell method, so units cubed there, whatever. Questions?